Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this section, we are going to learn how to build a game with C++ in Unreal. So join me in Unreal 5. I have launched the Unreal 5 engine. Here I'm going to select a game template for my starting point. You could use a blank project with absolutely nothing to help you start with, or you can choose from some of these templates which have some pre-built functionality already inside of the game to help you get started faster. For this project, we're going to be using the first-person template. This will allow us to have some basic first-person controls already implemented in the game. We could do all that from scratch, but it's not required. With these templates, we can get up and running really quickly. For the project defaults, select C++ as the project type. Note that it doesn't really matter which one you choose. You could use Blueprint or C++, but we're going to choose C++ because that is what we're going to be using to build the game functionality in this course. But even if you chose Blueprints, you could add C++ after. The target platform will be desktop. Quality preset will be maximum. We can enable starter content, but it's not required. This will give us some assets, materials, and textures for our game, and we don't need ray tracing. Then pick a location for your project, and let's save it. I'm going to call this my first-person shooter. Then press the Create button, and that is going to launch the Unreal Editor. Here we go. We have our template because the Unreal Editor has launched, as has Visual Studio. We can press Update in the bottom right-hand corner to automatically update the project for Unreal 5. Right here we have our content folder. You might see other folders as well here containing all of the possible C++ classes. Here in the viewport, we can look at the contents of our game just by clicking the left mouse button, holding it, and then moving your mouse around. You can run around this game with your camera. Here we have some default cubes and rectangular prisms and this walled environment because we're using the first-person template. If you press the play button at the top here, you can actually simulate the game. Okay, let me just drag the windows aside to make this a bit larger. If you want to move around in this game, just click once inside of your viewport here. Then you can use the WASD keys to run around, and you can click to shoot. All right, so by default, we have physics enabled on these cubes and collisions as well, because if I hit one of these cubes, they get moved around. All right, and also I can shoot projectiles at objects and they'll bounce off walls and off of the cubes as well. And again, I can run around and jump with the space key. So this is what the game looks like just as the template, right? So because we are using the template, we have this setup. You could build a completely blank project if you wanted to, but then you'd have to set up all these controls yourself from scratch. If you want to regain control of your cursor, then just hit Shift, FN, and F1 on your keyboard. All right, now I can actually move my cursor around, and the game is still in play mode. If you want to stop the game, just hit Escape or hit this Stop key. Okay, so I can hit Escape anytime. And that stops the game. I'm back in just the viewport mode. All right, here we go. We have our template set up. As well, Visual Studio should have opened too. Let me just pop that open. Not only did Unreal open when I created the project, but so did Visual Studio because the project type was C++. Right, so I can see in Visual Studio the different code of my template. If you go into Source here and then go into First-Person Shooter, you can actually see most of these are C++ files. One of them is a C# file as well as this target C# files as well. If you click on one of these, like first-person shooter character.cpp, which is the file extension for C++, here you can see some code is already pre-written for us, and that's because we're using a template. So this is all part of the template. For example, what happens when the character begins to play, and setting up all the input bindings to enable the player to jump and to fire, as well as to move. All right, so we have a lot of pre-written functionality. Feel free to dig deeper into all of these files if you're interested in seeing how the actual template was set up. Looking at the templates is a great way to learn how you can set up the basic functionality for different types of games, such as a first-person shooter. We're going to be editing a lot of these files as well as creating our own C++ files. Now, if Visual Studio didn't open or didn't generate your project files, you can actually generate them manually. Just find your project in your File Explorer, then right-click on the Unreal project, and here select Generate Visual Studio Project Files. All right, so you can generate the project files at any time. As well, make sure you do have C++ in Visual Studio. So you can at any time change what templates you have, what tools you have in Visual Studio by going to Tools and then Get Tools and Features. This will open the Visual Studio installer, even though we already have Visual Studio installed. So here we can actually install extensions to Visual Studio. For example, here I have game development with C++, and that's the one you want to make sure that you have. Because if you don't have game development with C++ here, then you won't be able to compile C++ code. Right, so make sure you have that one selected. If you don't have it here in your installation details, it means you just have to find it in one of the components available, and then you can just add it to your installation. I also have Python, but that's not required for this course. That's just from a previous project. All right, and now we have set up our project. Hello everyone, and welcome back to our course. One note about Visual Studio is in order to actually run and compile your Visual Studio projects with Unreal, you have to make sure you're running Visual Studio in administrator mode, which means whenever you open up Visual Studio, you have to right-click and make sure you're running it as an administrator if you don't have your default settings set up so that you're always running it as an administrator. Otherwise, if you don't have this run as administrator enabled, you can come up with problems where you don't have read and write permissions in order to be able to compile and send to debug the project in order to launch your project in Unreal with debug mode from Visual Studio. You can also just open up a project with administrator mode by using Shift and Control as you open the project. So you just hold Shift and Control keys on your keyboard as you open the project. So just keep that in mind. You do need to make sure you've enabled Visual Studio to run with administrator permissions in order to actually send that build to Unreal. You don't need administrator permissions just for writing code or building console applications, but for actually being able to hit debug and compiling the code that you wrote in Visual Studio with your Unreal project, you will need to make sure you're running in administrator mode. Join me coming up in our next lecture. We're going to write some C++ code as a quick win to get started. Hello everyone, and welcome back to our course. In this lecture, we're going to write our first C++ code for this first-person shooter game. It's going to be a quick win where we're going to write code for the projectile, where every time our projectile hits a cube, we're going to shrink the size of that cube. So for this, open up Visual Studio, make sure you're running it in administrator mode. And next up, we are going to open up the projectile file here, first-person shooter projectile.cpp. If you called your project a different title, then that project name will be here, followed by projectile.cpp. Here I've also increased my font size for you. And at any point, you can also drag around windows like that, and you can rearrange the windows in Visual Studio. All right, here we have our class for our projectile, which is that bullet that spawns from the first person shooter's gun. Let's go ahead and look for the function known as onHit. So I'm going to Control F and search here for onHit until I find that function. Here you go. We can see it's this void function. It takes in several different arguments here. We have hit comp. This is the component that was hit, which can be one of the cubes in the scene or any other object in the scene. This is also the component we need to shrink down whenever the projectile hits it. Then we have other actor. This parameter here refers to the thing that hit. Then we have other component. This refers to the component of the other actor, such as a mesh. We have normal impulse, which is the direction of the hit. And we have a hit result called hit. This provides a lot of information about the hit, such as the location of where the hit occurred. So this function onHit is going to run whenever the projectile hits something. And you can see we already have some default code here. We see we are only adding impulse and destroying a projectile if we hit a physics object. So here we're checking for if the other actor is not null. The other actor is the thing that hit. And if the other actor is not equal to this. So making sure that a projectile didn't hit itself. And if the other component is not null, remember the component, this refers to the component of the other actor. And the other component is simulating physics. So that means that the object has to have physics enabled for this onHit function to actually execute the code in the body of this if statement. So if all of these conditions pass as true, then we'll enter the code in the if statement's body. And what we're doing here is we're adding an impulse at a location of the actor. So we're just moving the actor that was hit. We're doing that by adding some velocity or speed to it. So that's why the cubes bounce whenever the projectile hits it. Then we're calling destroy, which is going to destroy the projectile that hit the cube. Because if a projectile hits something, then it's considered the end of the projectile's life. The projectile won't be able to hit two things. This is similar to a bullet going into a body. It can only really enter the body one time. Okay, so this is where we're going to add some code that's going to shrink the cube if a projectile hits it. So before we here add impulse or after we add impulse, we're going to shrink the cube. To do that, let's write some code inside of the body of this if statement. First, we are going to get the scale of the object that was hit. And the data type of that is going to be an F vector, and we'll call this scale. To get the scale of a cube that was hit, we're going to grab the other component, which is the component that was hit, and we're going to grab its function get component scale. All right, here then I am going to take the scale and I'm going to multiply it by 0.9f. So this means I'm going to reduce it by 0.9 or 90% every time it's hit by a projectile. All right, here we go. Now we have to actually apply that change to the object. So we're going to grab the object, which is other component, and we're going to call the function set world scale 3D. That is going to change the scale of the object. And we're going to change it by a value of scale. So we're just going to set it to a new value, and that new value is going to be scale, which is 90% of the component's previous scale. So it'll be 90% smaller each time. All right, and then that is going to, just like that, reduce the scale of whatever object was hit. As long as all of these if statements pass as true, then the object will be scaled down. And this destroy destroys the projectile, not whatever was hit. So we can already test this out by saving all of the files that we edited, which really is just this one file that we edited. Then we're going to click this button, Local Windows Debugger, or Debug and start debugging. You can also use the keyboard shortcut F5. So I'm going to press that. That is going to build and compile my solution here. And it's also going to open up Unreal. And this way I'm going to be able to see the changes made to my file here. I'm going to see those changes reflected in Unreal. All right, so let's go and launch Unreal. We're going to be able to see this time when we hit play in Unreal, as long as our solution is still running in Visual Studio. So you want to make sure it's still in debug mode in Visual Studio as you hit play in Unreal. Okay, great. So here is my same project. I'm going to press play. And this time, look at that. Every time I press my mouse button, I fire a projectile. And look at that. Every time a cube is hit, it gets smaller. But if I hit a wall, it doesn't get smaller. We can also turn off sound. So let me just escape this. And I'm going to go back into Visual Studio and stop the build. To turn off sound, go into your first-person shooter character.c++ file and just Control F for sound. Here we have a function being called that plays a sound at a location where the fire sound or firing a projectile is called. So what we can do is we can just select all this and comment it out. For example, by hitting Control K followed by C. That is the keyboard shortcut to quickly create a comment, or you can just manually add the comment yourself with either these 2 forward slashes or the forward slash and asterisk surrounding the lines. All right, so that is just going to comment out or hide this line from the compiler. So this line will no longer be registered by the compiler. It's just here for us to read as a developer. Now, if we save our file and we hit Local Windows Debugger or F5, then we're going to relaunch Unreal. And now we'll see that the sound will actually be gone. And at any time, you could uncomment that line to bring it back. So now if I press play, I can shoot and no longer do I have any sound, but my cubes are still getting smaller. So notice I can run and shoot at a cube and it just gets smaller. We can also delete the cube when it gets too small. Let's hit escape to stop the game and then just close that Unreal editor. You can also press stop in Visual Studio and that will also close that instance of the Unreal editor. Now we can make a change inside of Visual Studio again. And every time we make a change in Visual Studio, we need to hit debug and then start debugging, or just Local Windows Debugger, in order to compile all the code that is new. Once you've compiled it one time, then it will be saved in Unreal. Okay, so let's go back into our first-person shooter projectile and go back to our onHit function. Here you'll notice we just reduced the scale of a cube whenever it was hit. So we've written our first C++ code for this game. We can also remove a cube from the game if it gets too small. So for that, I am going to add in an if statement before I set the scale of the component. I'm going to check if scale.getMin is less than a value like 0.3f. So I'm checking the value of scale with this getMin function. And anytime you're confused about a piece of code, just hover over it to get a description. For example, here we can see that getMin returns the minimum value of the vector's components. Because this scale is not just a number like 1, it's actually a vector. A vector is a series of 3 values, x, y, and z, because in our 3D game, every 3D object is going to have a scale on 3 axes, the x, y, and z. How wide it is, how tall it is, and how deep it is. So that's why scale, we need to use getMin to check its smallest value of its 3 values. So if scale is reaches less than some threshold like 0.3, then we could destroy the cube. And we could put all of these numbers into variables just to make it a bit more clear what they all mean. That's something I would highly recommend for doing code optimization or cleaning up your code to make it more understandable to other people. You don't want to leave what are known as magic numbers, which are numbers that are just left here in the code without having some kind of variable or constant attached to them. For example, I could make my 0.3 into a float that I call my minimum cube size, and I could set that to equal 0.3f. Now it's a bit more clear what my 0.3f actually means, instead of being an arbitrary number that might be confusing. So if our scale of the other component is less than the minimum, then let's go ahead and destroy that cube. So I am going to call other actor, and I'll call the destroy function to destroy that. Notice this is different from the destroy function we already have, which refers to just this class, which is the projectile. If you just have destroy here, it means we're destroying this class or object, which is a projectile. But if you're calling other actor destroy, then we're actually destroying the other actor. All right, so there we go. We can now test that out. We're checking if our scale min is less than minimum cube size. Notice that, however, we still have this line that sets the other component. So you have to think through this logically. How are we going to set the scale of a component if it's been destroyed possibly? Well, for that, what we're going to do is append here an else statement. Okay, so I'm adding here an else statement, which is only going to run if the if statement does not run. And in that case, I can set the world scale of that cube. Otherwise, I can't set the scale of the cube because it's been destroyed. And we can't change the scale of something that has been destroyed. Also note, typically with formatting your code, you want to have a bracket on its own line. It can be different at each company, what they prefer in terms of their code formatting, but this is the most popular formatting you'll see, where you have each of these brackets on their own line, just because it makes the... Hello everyone, and welcome back to our course. In this lecture, we're going to learn how to build an enemy controller with C++ for our first-person shooter game. So pop open your first-person shooter game, whether that's via the Epic Games launcher or just via your own file explorer. Open that Unreal project. Next, let's go into our content browser and go to the folder C++ classes. This stores all of the C++ files for our game. We have a first-person shooter character, first-person shooter game mode, first-person shooter HUD, and first-person shooter projectile. These were all built for us because we're using the first-person template. Let's go ahead and create our first new C++ class for this game. So I'm going to select the Add button here, and I'm going to choose New C++ Class. Here, we can then select a parent class. We're going to choose an actor. We want an object that can be placed or spawned in the world. Okay, then press Next, and let's give this actor a name. I'm going to call this our Enemycontroller. That is also going to be the name of our C++ and our header files. The class type can be public. All right, next up, let's hit Create Class, and that is going to pop open Visual Studio with our new class added. You want to make sure that if you had any previous instances of Visual Studio, you can get this message: the project first-person shooter has been modified outside the environment. Make sure to press Reload All. That is going to reload your project with that new file change, because now inside of Visual Studio, we should see enemycontroller.cpp and enemycontroller.h. Okay, so there we go. All of that has been created, and they've also opened up. Inside of Unreal here, you should also see Enemycontroller now appear inside of your C++ classes project folder. If you don't see this, it means that likely it wasn't created properly or you didn't reload all. So you can try closing your project and reopening it to see if it comes back, or just recreate it again. Make sure when you're making a change to Unreal that you don't have anything in Visual Studio currently running, because that can sometimes cause the project not to save properly. All right, great. So we have Enemycontroller created. Let's go ahead and open that in Visual Studio. We have two files, the C++ file and the header file. We already have some default code created here because that will be generated whenever you create a C++ file from Unreal. We have some includes, which refer to some external files that we need to use in this file because they have some properties or functions that we have to use in this file. We have our project name followed by API, and then we have this class created called Enemycontroller. You'll always have A being added to your class name. You'll notice it is a child of the Actor class because we selected the parent class to be actor. Then we have a public constructor. We have a protected function, begin play, which is going to run when the play button is pressed or the game begins, or when an instance of this class is made, such as when an enemy object is spawned. And we're going to have multiple enemy objects spawned. We also have a public function tick, which is called every frame of the game. That is quite often. Typically games can run at 30 or 60 frames per second. We also have a C++ file. Note that it has to include its header partner here. Next, we have the actual implementation of, for example, the constructor. Here we have primary actor tick.b can ever tick equals true because we want the tick function to be enabled. Then we have an implementation of begin play, just calls to the super begin play, which refers to its parent. The parent of an Enemycontroller is an actor, which is what we set. Then we have tick, which is the implementation of the function that's going to run every frame. You can put your own code into begin play and into tick and into the constructor, and that is what we will do in this project. All right, let's get started inside of Enemycontroller.h. Our first step is going to be to create our enemy. So let's go into public here and let's create a public property. So make sure you have this line indented once to make sure it's under the public section here. It's public, which means it can be accessed outside of this class. And I'm going to specify that this is a U property and that it can be edited anywhere. That is going to be the header of my property. Then I'm going to call this a U shape component type that I will call root box. All right, here we go. So now we can put to use this property. You may notice here we have this red underline. So let's just save and go to build and build solution in order to apply the changes that we just made, because sometimes changes can take some time to apply. If you get an access denied message in your output, it means you have to open up your project or your Visual Studio with administrator access. All right, so here we go. We now have the red underline gone because we built our project. It can take time for some new code to get updated and integrated into the project sometimes. So that's why we hit build in order to just speed up the process. This root box is going to refer to the box that is the enemy object. Next, let's create another U property. And again, it's going to have edit anywhere access. I'm going to make this a floating point number and I'm going to call it speed. Then let's set this to something like 100.0f. Feel free to have indents if you like. This is going to refer to how quickly the enemy can move because it's going to be chasing our player. Again, if you find that the code has not been integrated quickly enough, go to build and build the solution. That's going to just update your code to integrate with the existing code. Of course, that's not required because whenever you hit debug, that is going to compile your code. If you do get access denied, then reopen your project with administrator access. Next, let's declare a function that is going to run whenever the enemy collides with something or overlaps with something. So I'm going to declare a function. It will be void. And here I'm going to call it onOverlap. This is going to take in several parameters. First, a U primitive component. And this will be called the overlapped component. Next, an actor. And this will be called other actor, followed by a U primitive component that we'll call other component. So you can see some resemblance here to what we had with our projectile. We're also going to have an int 32, which we'll call our other body index, a boolean called b from sweep, and a const f hit result that we'll call our sweep result. So this is the setup for creating the onOverlap function. So make sure you have your code exactly as we do here. And if it doesn't compile in time, then just rebuild the solution in order for all the little red lines underneath to be removed. They'll be removed as soon as the build completes. Let's just wait here for all the actions to process. And you'll also be told if you have any mistakes here. For example, here we have an unresolved external symbol. So let's see what we might be missing here. We have an AA actor, a U primitive component, an other body index, B from sweep, and F hit result, sweep result. Okay, there we go. Everything has been compiled because our red lines underneath have been removed. Okay, next you'll notice onOverlap has a green underline because we need to actually fill in the body of this function inside of the C++ file. For that, let's go into Enemycontroller.cpp. Here, we're going to enter our constructor. And first, I'm going to take our root box, which comes from Enemycontroller.h, and I'm going to create it using createDefaultSubObject. This will be a ubox component. And I want to give it the text of root. In order to be able to use the ubox component, we do have to include its originator, so where this comes from. We have to include that at the top of our file here. So I'm going to add here #include, and the box component comes from components/box component.h. All right, so now we will be able to use that ubox component. There we go. And also for this text, just don't forget that second parentheses there. Okay, great. So now we have defined our root box. Let's go ahead and enable overlapping events before we actually build out our onOverlap function. Next, I'm going to enable overlapping events. So I'm going to grab the root box and use set generate overlap events and pass that to equal true. And here it's a function, so I'm just passing in true as a parameter. Okay, there we go. Next up, let's also enable for dynamic overlapping. So let me just add a space here. And next, I'm going to grab the root box and call the function onComponentBeginOverlap. I'm going to call add dynamic. Then I'm going to pass in this, which is the enemy controller, followed by at a enemy controller on overlap, which is that function that we created. All right, so we can see onOverlap is a helper macro to bind the object instance and a function into a dynamic delegate. So this means when the root box begins an overlap, we're going to call onOverlap of the enemy controller. So our enemy controller is what's going to handle overlapping events. Next, let's go ahead and declare our onOverlap function. And it has to have the same parameters as in this Enemycontroller.h. So we can actually just copy that function. Let's go back to the C++ file and just paste it somewhere. Notice that it has to match what is inside of the header. Okay, but this time we're actually filling in the body of this function. As well, we have to specify where it comes from. It comes from a enemy controller. Okay, so we use the double colon here to specify that we're filling in the body of the function that was declared in the header file. So what should we do in here? Well, first, let's write an if statement to check when our enemy collides with another actor, such as the first-person player. When the enemy collides with that first-person player, we could end the game, or we could pause the game, or just reduce the enemy's health. Whatever we want to happen, we can also reduce the player's health. Whatever we want to happen when the enemy touches another actor, such as our player. So how do we check what was part of the overlap? Well, that is what all of these parameters are there for. That's why we have this overlapped component and the other actor and the other component. So I'm going to check if my other actor equals uGameplay statics get player character of this world. So I'm going to grab the world by using get world and checking if it's player 0. To enable uGameplay statics, we do have to include it at the top of our file. So I'm going to go to the top here and I'm going to include with hashtag include kismet/gameplay statics.h. Just make sure that the enemy controller is up top. This will allow us to use gameplay statics, which we need. And here we're going to get this message that there's a conflict between comparing the actors, because here we're comparing an actor to a character type. So first, let's go ahead and grab the character of this actor before we actually can put it to use and compare it to see if the other actor, which is what the enemy collided with, was the first-person player. So here I am going to create a type A character, and I'm going to call this collided with because it's what character the enemy collided with. And I'm going to assign this to equal our actor cast to a character. So I'm going to take a character and I'm going to cast my other actor to the A character. That way I can now check what that other actor is. We're checking if the actor cast to a character that the enemy collided with or overlapped, we're checking if that is equal to the first player character in this world. Because here we're using get player character, which takes in a world and a player index. And if we have just one player, then 0 is that first player's index. If this passes as true, it means that our enemy collided with our first-person shooter. So we can perform some action here, like we could reduce the player's health, or we could stop the game. Let's start by just pausing the game. To pause a game, we're going to call uGameplay statics, and we're going to call the function setGamePaused. Here, we're going to pass in getWorld and true, because we're pausing the current world. SetGamePaused takes in the world that you want to pause and a Boolean true or false value, be paused, which is short for Boolean paused, And it's basically saying, do we want to pause, true, or do we want to not pause, false? Now let's save all of our edited files and let's hit debug to compile our code. This is also going to launch Unreal. Now, if we currently press play and test this out, we won't see our enemy appear yet because we actually need to add our enemy to the game. We need to add it manually via Unreal. So join me coming up in our next lecture where we're going to add our enemy to our Unreal project. So we will connect the C++ code to some actual object in our game. Hello everyone and welcome back to our course. In the previous lecture, we learned how to write C++ functionality so that whenever the enemy collided with our player, we wrote the functionality to pause our game. If we want to actually test out that functionality, we need a visual component to our enemy. Otherwise, if I press play, I'm just running around this game, but my enemy doesn't actually spawn. So let's actually create our enemy inside of the game as a visual component, and then we'll be able to see whenever we collide with that enemy, our game will pause. So close any debugging runs of your Visual Studio solution and just open up your Unreal project. Here we are going to add a visual component to our Enemycontroller. So we have here an Enemycontroller in our C++ classes folder. And we could just drag that right into our game, and we'll see if we press F, we can zoom in on this. It's just this invisible box. So let's make this a visible box instead. I'm going to go into the details window and add a box that we can actually see. I'm going to add a mesh. If you don't see the details window, go to window and then select details and open up a details tab. Then here, I'm going to press the add button in the top right hand corner of the details window to add a new component to this actor. Here, I'm going to select a cube. And now look at that. We can see our enemy looks like a cube. Let's change its material so that way it stands out from all of the other cubes, because this isn't just a cube, this is an enemy. So this cube has all of the C++ functionality that we wrote. I'm going to change its material in the materials tab here. For example, let's see, we did enable starter content, so we'll have a lot of materials here, such as gold. If I give this a gold material, look at that. Now my enemy is differentiable. Okay, and I can press Control S or Control Shift S to save or save all. Okay, now I can press play and I will actually see my enemy inside of my world. I just have to rotate around and there it is. I can also hit my bullets off of it. You'll notice though, if I touch the enemy currently, the game doesn't pause. So there's one more thing we have to enable. We have to change how the collisions are being processed. So let's click on this Enemycontroller and I'm going to click on the cube object specifically. Okay, so not just the root box, which is the root of the enemy or the enemy itself, but actually on the cube mesh. That is the gold visual here. And I'm going to go to the collision tab here, the collision component. Here, I'm going to change the collision presets. Instead of using block all dynamic, which is typically a default collision preset of a cube, I'm going to change this to no collision. That way, the collision will be processed by my root box instead, which actually comes from my C++ file. So now I can test this out again. Okay, let me rotate around. I can still bounce my projectiles, but look, once I touch the cube, my whole game froze. That's exactly what I wanted. It didn't just freeze because of a crash. It actually froze because we set it in our C++ code to freeze or pause the game when the enemy collided with a player. We wrote that in our code and we compiled the code, so that's why we're seeing that now. So you'll notice as soon as I touch that cube, the game pauses and I can't move around anymore. I have to hit escape to stop the game. Later on, we can write functionality to actually allow the player to manually restart the game via the user interface of the game. All right, so what we had to do is give this instance of an enemy in our world a cube and also change its collision presets of the actual cube itself. So not of the enemy controller, that doesn't have collision. Well, it does have collision, but not the property we want. Root box here also has collision, but what we really want is the collision of the cube to be no collision. And that is how we can test out the functionality that we wrote in C++ in our game. And this proves that the code that we wrote actually works. All right, next up, we're going to create a game mode that will control the game. And we'll build a game mode that can actually spawn multiple enemies randomly throughout the game. So join me in our next section. We're going to learn how to dynamically spawn enemies with C++. Hello everyone, and welcome back to our course. In this section, we're going to learn how to dynamically spawn enemies with C++. For that, pop open your Visual Studio project for your first-person shooter game. Here, we're going to make edits to our game mode. Because we used a first-person shooter template, we actually have a game mode already created for us. We have the header for our game mode and the C++ file for our game mode. All right, so these are some short files. We're going to make edits to these files starting in this lecture. Let's begin inside of our header file. So let's pop open that first-person shooter game mode.h. Here, let's start by creating a new property. And this is going to be a reference to an enemy blueprint that we'll create later. Because if we want to create multiple enemies, we have to make that enemy reusable. And we'll do that by turning it into a blueprint in Unreal. So let's make this public so it can be accessed via Unreal. And here I am going to create a new U property. I'm going to make it edit anywhere, which means I can edit it in Unreal. And I'm also going to give it a category. And let's call this our spawn category. This will allow us to actually see it in its own category in Unreal. And I'll show you that later on. Next, we'll specify the type of this property. This will be a T subclass of, and then we are going to specify our class, which is a enemy controller. Because our blueprint will be a subclass of our enemy controller. And let's call this our enemy blueprint property. Next, we're going to need a float to keep track of how long we have between the times that enemies have been spawned. All right, so here I'm going to create a float. I'll call this my enemy timer because we're going to generate enemies every 2 seconds, let's say. So every few seconds we'll generate a new enemy. All right, next let's open up our corresponding C++ file. First-person shooter game mode.c++. And let me just make this window a little bit bigger. All right, here, first we want to create our tick function. Okay, so we need a tick function to specify something that we want to happen every frame of the game. If we want this to be created in C++, we'll also have to create a match for it inside of our header. All right, let's create here a void, and then we'll specify our game mode as the data type or the class where the function is going to be declared, and we'll call this tick. Every tick function takes in a float delta time, which is for the passing of time. Okay, here we're going to make a super call to tick of delta time, super referring to whatever is the parent of this game mode. Now, if we want this code to work in the C++ file, we do have to create a corresponding declaration for the function inside of our game mode.header. So let's go back to this header and let's just create that tick function. It'll be public as well. Here we are going to declare our virtual void tick function. It's virtual because it's not implemented in this file. It's void because it doesn't return anything, and we're naming it tick. And then it's going to take in that one parameter, a float of delta time. And finally, override, because we're going to override it in the C++ file. All right, there we go. Here we are declaring that tick function. So that matches up directly with the implementation in the C++ file. We can also do the same with begin play. We can declare here a virtual void begin play override, which will run when the game begins. Then we do have to implement that inside of the C++ file. And again, it's similar to tick here. We're going to call void here, and then first the game mode, a first person shooter game mode. That's the name of our game mode class. And then we're going to call that function begin play. All right, and inside of the body of the function here, we're going to make a call to super begin play, calling to its parent class. All right, there we go. So now we've declared our begin play and tick functions. Next, let's begin by making an enemy timer. Let's see, we already had that declared here, but then let's reduce this enemy timer each time our tick function runs. For example, this can start at 0 and then we'll reduce it. And every time it hits 0, we are going to spawn a new enemy. So we'll have to set it to a certain number, like for example, 2 seconds, and then set it back to 0. So let's go into our C++ file and let's implement that functionality inside of the tick function. All right, so here inside of tick, I'm going to take my enemy timer and reduce it. Note that the super line has to be the first line. We'll write the rest of our functionality below that. We'll take enemy timer, which was declared in the header file, and we'll reduce it by delta time. We're using delta time here to ensure that the game runs at the same speed regardless of the processing speed of the device. For example, some devices could run at 30 frames per second, some devices could run at 60 frames per second, but we use delta time here to ensure that the speed will be the same regardless of the frames per second. All right, then we're going to perform a check. We'll check if enemy timer has reached less than 0.0f. If this condition passes as true, that means we are ready to spawn a new enemy. So the first time the tick function runs, we'll spawn an enemy, but then after that, we'll set enemy timer to some value. For example, let's say we set enemy timer to equal 5.0f. All right, this means we're setting it to 5. So the next time we'll spawn an enemy will be after 5 seconds. So after this value has gone down to 0. Now, how do we actually spawn the enemy? Well, for that, we can spawn a new actor in our world. All right, so for this, we're going to need to call the spawn actor function, and we need to pass in a blueprint as well as a location and a rotation for the actor that we're spawning. Okay, so if we go back into the header, we can see here we already have a property that is our enemy blueprint. We'll have to fill this in on the Unreal side because we haven't created the blueprint yet for the enemy. We'll do that later. But we can assume that it has already been implemented in this file. The first step is going to be to grab a reference to our world with the function getWorld. All right, then we can store that as a uWorld type that we will call the world. All right, then we're going to check if world is not null. So if world is true. And you can just use the shorthand of if world. So if the world actually exists, if it's not null, then let's go ahead and spawn an enemy around our player. So in order to do that, we're going to grab the world and we're going to call spawn actor. Here we go. And for spawn actor, we're going to pass in our type, and that is going to be our Enemycontroller. Here we go. Next up, we need to pass in the arguments for the spawn actor function. Okay, we can pass in here some parameters. I'm going to pass in my enemy blueprint, which comes from the header file. This is the blueprint for the actor I want to spawn. That determines the visual. And then I'm going to also pass in a location. So I'm going to here create an enemy location variable, as well as a rotator. I'll use F rotator 0 rotator. This will implement a container for rotation information. And here we just have a rotator of 0 degrees on each axis. So now we have to define enemy location, because we can call spawn actor, but we want the enemies to be spawned in random locations around our player. So how do we set the enemy's location? Well, the first step is going to be to get our player's location and then spawn the enemy somewhere nearby, because we don't want the enemy to spawn too far away. So first, let's get our player's rotation. Okay, so for this, I'm going to create an F vector data type, and I'll call this my player location. It's an F vector because it stores a series of X, Y, and Z values. It stores 3 values, one for X, one for Y, one for Z. Because location in a 3D world, it's not just one value or even 2. In a 3D world, you have to know where the player is on all 3 dimensions. All right, so that is declaring the variable. Now let's actually give it a value. I'm going to use uGameplayStatics, and I'm going to use the function getPlayerCharacter. Okay, this is going to allow me to get my actual first-person shooter. Now, for uGameplayStatics to work, let's go ahead and import it. So I'm just going to go to the top of my file here, and I'm just going to include it. So I'll have here include kismet/gameplaystatics.h. And also, because we're using the Enemycontroller type to spawn our enemy, I'm going to also include Enemycontroller.h. Okay, so now we can scroll back down and we'll be able to use uGameplayStatics. Let's just pass in here the required parameters. So in order to get a player character, we have to specify the world from which we're getting them and also the index. Because if there were multiple players, we'd have different indices for each player. So first I'm going to get the world with the function getWorld. I could also just use my world variable. And then I'm going to pass in the player index. So let's just create here player index. All right, then I'm going to create that as an int player index. And because we only have one player in our single player game, our player index is just 0. Okay, now you'll notice here, this just returns for us the first person shooter player. If we want to actually get their location, we have to add here the function getActorLocation. All right, so there we go. Now we're able to get the player's location. Now the enemy's location we can set to be just around the player, but nearby. So first, let's declare another F vector for the enemy location. And I'm going to assign it initially to equal the player location. All right, there we go. Now we have all of our error messages gone because we've created all of the required parameters for this spawn actor function. But here, I want the enemy location to be slightly away from the player, not exactly right on them. So let's go ahead and just move them slightly away. I'm going to grab here enemy location, and I can change one of the values, like for example, the X value, I could here change this to be a random number. Okay, so I can just add this and I can set here some random distance. And then I can multiply, let's see, random distance. Okay, so here I'm just going to change on the x-axis. I'm going to add a random distance. So what is my random distance? Well, let's determine that. Let's create here a float. I'll call this my random distance. And I'm going to use fmath. And I'm going to use the rand range function, which is short for random range. It allows you to choose a value randomly among a range. For example, you could have your range be from 0, but that's a little too close, maybe from 10f all the way to, let's say, 1000f. Okay, and we can check how far away that is if that's too far. And let's see, let's just add here 0.0 or 0.9. Let's see, let's add 0.0 for these floats. Because this random range function, it needs us to pass in here floats. Now we have a random distance, and we're going to be changing the enemy's location to be slightly farther away from the player. We could also do the same on the Y if we want them to be offset on the y-axis as well. The z-axis we could do as well, but that would determine their up and down, and we don't really want them spawning below the ground. So I'm going to leave the z-axis as is. All right, there we go. That is how we can place our enemy with the spawn actor function. We can also store the result of this as an actual enemy controller that will call our enemy. All right, so there we go. That way we have a value returned by spawn actor, which is of type Enemycontroller. And that is going to be this enemy. And a new enemy will be created every time the enemy timer goes back to 0. And because we're using Enemycontroller, we have to include that header file here. One more thing we have to add to our code before we can then build our blueprint and test out the code is we have to add a line into the constructor of our game mode C++ file. So let's add a line, and this line is that we have to say that we can enable tick. Otherwise, by default, the tick function is not going to be enabled. So if we want to enable the tick function, we have to call primary actor tick dot b can ever tick. And we have to set this to equal true. This means that our tick function can actually run every frame of the game. Otherwise, none of the code in your tick function will run. So make sure you include that line, again, in the constructor of your game mode C++ file here. All right, now let's save and let's go ahead and debug this, or compile by hitting debug or F5. And that's going to compile our changes. Next up, if we want to actually see these changes in effect, if we want to see all of our enemies being created, we have to build blueprints for our enemy, as well as a blueprint for our game mode. So join me coming up in our next lecture. We're going to build out those blueprints, and we're going to build out an enemy blueprint so it can be reusable, because currently this is not reusable. And as well, we're going to build a blueprint for our game mode so we can set that as the game's default game mode. All right, so let's go ahead and stop our build. We can stop it now that all the code has been compiled. We just had to hit that debug one time, so that way all of our code compiled. I will see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.